automotive industry is going through disruption. It's four major forces that are really driving that disruption. It's basically the connected cars, the autonomous cars, electric cars, and the shared cars. So all of this really drives the need to go beyond just developing a vehicle and sell it to the customer. There is more than that. We are providing an environment to test things live. So we're talking about a high level of technology readiness. So we're talking about something that is, you're ready to market. You've seen today, so we've got the Defender and we have an I-Pace, which were both loaned by Jaguar Land Rover as a contribution to the project. So we kitted out all of those with state-of-the-art technologies like the LiDAR, the radars, the cameras. We went really into the high spec for all of what is available on the market. So the intention is really to make all of this equipment, which is very expensive to build, is to make it accessible to all sorts of companies from startups, SMEs, multinationals. Instead of them investing in building a car like that, which costs like between 300 and 400k, it's basically for them, it's going to be just rented on a daily basis, on an hourly basis, depending on their need. Right, and then on top of that, like the vehicle itself, so we have also the control center and the workshops area. So we've seen the construction site there. It's basically workshop bays which are fully private. They can be closed for companies to bring in their vehicles or use our vehicles to fit out their equipment, to test all of the technologies on them, and then take the cars out and do the drives and collect the data and do all of the research they are developing.
When we were working with Jaguar Land Rover, there was a lot of ideas that we personally had that we wanted to create products based on the concepts that we had. So that's really where we wanted to create this playground, for things that we wanted to do personally. And that was where we stretched that further. And we realized this wasn't only us that wanted to do it. There was lots of people that had similar ideas, that they wanted to do similar concepts. So that's where the idea of FMCI, it allows different companies or startups or just individuals or research agencies or whatever to come in and try new things, and based on different levels of readiness. It could be just a pure concept. I want to manipulate some data and I'd like to really see where I could push that to, applying machine learning, AI, all of this kind of cool stuff. Or it could be something much more product ready, where it's like, this is my new box, I need to see how it works in the performance in the field, I want to try it at FMCI and go from there. I think a big piece of what we offer though as well is that the ability to pull companies and people together. Like that's very important with what we have. We have a lot of great partners. Yeah. The reason why they came together is because they all had a vested interest in working together. There was something they all wanted to get out of it, but it was all built on top of what other companies have put in place. Because this what we're talking about, these cities of the future, no one can do them by themselves.
We're not only here as a testbed for mobility, we're here a testbed for future mobility. Future mobility is not only vehicles, but it's also moving people around, moving packages, moving robots on the street, moving lots of things around us, right? So all of that as well, as there is a shift now towards the green mobility as well, which is part of our remit, let's say. So our identity is to allow the testing, the validation, and the evaluation of whatever goes into the future mobility and the future smart cities as well. Like a company that can come up with an idea of, okay, how can I, for example, charge the vehicles or schedule the charging of my vehicles or my fleet in order to maximize the use of the road, but as well as optimize the use of the grid. I don't want to overuse it because there are citizens in the same area that are using it for other purposes. So we need to kind of do that balancing, and that kind of informed decision that is needed for whoever owns the infrastructure or who wants to upgrade the infrastructure, how and when and who needs to upgrade it and how. These are kind of things that will be taken from our data. We're not going to be informing these decisions, but we will be providing the data to allow for a sustainable development of the entire smart city or smart campus that we have here.
Where to next? So I think we've already started on our next phase of development. So a big part of, we focused initially on road because of our background and where we came from, but now we're also looking at air. So we're looking at a lot around advanced air mobility, drone delivery, how we're going to move people and goods in the air in the future. A lot of the same problems need to be solved for road and air. Again, it's like nodes on a network or data paths. How do you fix all of these objects flying around both on land, road and air? Where we see this going, we're not sure if it's going to be air taxis everywhere or if it's going to be autonomous vehicles everywhere in the next 10 years. I don't think anyone can really tell that. We're going to see flavours of that, but we know it's not going to be ubiquitous. It's not going to be, as much as we would love it to be ubiquitous, where we just take air taxis everywhere. That would be nice. There's easy ideas out there that are still yet to be discovered, I think, that, and they're going to be like big ideas. It's going to be, oh wow, why didn't I think of that type thing? A lot of that's going to come out of what we're looking at, and that's kind of what really keeps us excited about what we're doing.
A big push from our side is that when we saw this happening, we saw the kind of where we can go with it. So we didn't want just to hire people to go and build it, but we wanted to do it because we know that there is an excitement, there is something that started as a concept, a conversation in around a coffee, but then it evolves into, look at this huge project, right? The idea is also to be involved in it because we do have our dreams that we wanted to build, and then we are building the ecosystem for it and probably helping others to build those dreams for us, right? So of course not for us, but to come here and attract their ideas and bring them over to come up with their also crazy ideas and show us what we can have and what we can see in the future. If you have an idea, just come, we'll build it together. And I'm really here to do it, and I'm really here to support not only me, Russell, and all the other partners that we have in FMCI and all the ecosystem that we have here. It's really here a very good playground for anyone coming with any idea. Just come. Even if it's just for a chat and a coffee, we're open for that. If you want to move it towards production and testing, we're more than open for that as well.
Hi everyone, welcome back. It's Dave here. We're here to follow on the conversation we had just earlier with Wassim Derguech from the Future Mobility Campus Ireland. But it's great to have you here in person with this wonderful piece of kit that's behind you. So you've brought along your toys, which is fantastic.
Absolutely.
And look, let's use this opportunity to find out what this vehicle actually is, what it does, what its use cases are. So I'm going to hand over to you, Wassim.
Very good, thank you very much. Well, as you know, Future Mobility Campus Ireland is a test bed for future mobility, and we were talking about mobility. It's all about moving objects and people from one place to the other, and especially when you talk about the future, we talk about autonomous, connected, shared, as well as electric cars. So here we have a PHEV vehicle, the recent iconic car from Land Rover, the Defender. So as you can see, there's plenty of boxes on top of it. So those boxes are all of the potential sensors that are needed to make the car sense all of its surrounding and make sure that it identifies people, vehicles, roads, all the obstacles, etc. So we can see like there are boxes there for radars. There is the HESI LiDAR on top of it. And there are also some cameras as well. The car itself, it has also some surround cameras, etc., etc. So the good thing is that this car is not just only for FMCI or for FMCI development. It's for all the potential customers, developers, SMEs, startups that want to come and do innovations for the future of mobility. And you can see here an example. These boxes here are actually developed by one of the startups that is set here in Limerick. And they're using this for developing their technology for preventing accidents on the road.
So you might take us around to the interesting part
Absolutely.
of the brain, and let's talk about that. It's a beautiful, beautiful vehicle.
Absolutely. As you can see, like this is one of the state of the art and the most recent vehicles on the road. Mm-hmm. Probably on its own, it cannot really do much except maybe assisting the driver. But what we're doing here with the kit on top as well as the kit at the back here, we're giving it more capabilities in terms of perception of its surrounding or its environment with all of these sensor kit on top. Mm-hmm. And like we've been discussing as well about there's a lot of local innovations as well in place here. So apart from the sensors, also the antennas that allow the vehicle to communicate with the GNSS or with the 4G or 5G networks. These are developed by a local company, an SME, Towglass here in Ireland. So If we dive into as well the hardware stack, so at the very bottom here is quite obvious. We want to start with the power management, right? So that's basically converting the power coming from the battery of the vehicle and making it available for all the other hardware to be used in there. So on top of this, obviously we've been talking about antennas, and we want to also the sensors, and we want to get all of the data from those sensors. So this is the kind of our logger. So the logger allows us to connect each of these sensors into it, convert all of those signals into readable data, and then storing the data into the storage option. Here, this is a large scale, let's say, storage solution which is provided by Seagate, one of our partners. So all of that is also needs a bit of compute. So during the compute, it's basically understanding the data, identifying the safe spots where the car can move into, as well as filtering some of the data that we can communicate or send to the cloud, because obviously we're collecting a lot of data here and we cannot send everything with the connectivity. And then here we're getting a lot of support as well from Cisco in order to guarantee that there is communication with our control center to grab the data and do more data processing afterwards.
Okay. It's fascinating. I mean, it's a lot of hardware. It's a lot of technology, in this vehicle. What do you see, and really what sort of timeline do you see where a lot of the, miniaturization of this, making it into vehicles then that actually can be, readily available for citizens? And obviously you've got to refine the technology, but also shrink it, I'd imagine, somewhat.
Absolutely.
In terms of the physical scale of the vehicle.
Yeah, well, don't forget that this is a test vehicle. So this vehicle allows companies or anyone that was going to come and rent it to do data collection, data analysis, visualizations, etc., etc. So that's why what we have here is really the Rolls-Royce of everything. Like all the bells and whistles, like to make the car, give them the capability to get everything. Like one of the options, for example, here, data storage. We might not need data storage in the future in autonomous cars because everything will be communicated to the cloud. But there is already a lot of advancements in here, like you said. So you can see here the Seagate. This is, it's very funny to see it. This is very modular. Once you finish your test, you go and take this, put it in the data center, collect your data, and do all of your analysis in-house. So this unit here has 96 terabytes. So, and that's, maybe you can see like it's a huge, it's also heavy, but 96 terabytes, depending on the configuration of your sensors, it might be just 1 hour of driving.
Right, of course, yeah.
So, optimizing the hardware is something that is of interest to all of the partners, and not only from data perspective, but also data processing. We hear a lot in the tech space, a lot of advances in speeding up the processing of data and the management of data analysis and machine learning, AI, all of that needs a lot of compute. We don't necessarily need everything in the production cars. We might need a very smaller version of it. But again, to get to that point, we need to understand how the vehicle collects the data, analyzes the data, and do all of the actions.
This is a sophisticated test bed for future, and that future, we all look forward to.
Absolutely.
It's not too far away from us.
Well, look, I have always been saying that it's still 5 years to 10 years from now, but this car can do it, right? It can do it. It can be tested tomorrow on the road. But the thing is that we're still far from being confident enough to give it to the public. It needs a lot of development, needs a lot of analysis, etc., etc. Well, and Ireland is perfect place because we have a lot of nice roads, very nice weather that helps us to overcome all of the challenges that technologies need to solve.
And look, let's face it, we seem to have the talent locally as well, the collaboration and the coming together of a lot of different parts of the puzzle to actually make, through the organisation, the Future Mobility Campus Ireland, to actually make these great developments. Wassim, really thank you for being here with us, and to Russell as well. It's really exciting, and I hope you found that interesting. Hello, Gary. Hi, folks. Again, it's Dave back with Gary McMahon, who you met just earlier on our panel. And part of the conversation with Gary then was the counterpoint between a lot of what we're talking about innovation from the point of view of technology and emerging technologies. But really, Gary's World is one about uncovering the old traditional crafts and skills and actually making it actually happen. So Gary, I'm delighted you're here live with a City One, which is one of your one design items that you produced back in 2014, I understand, for the City of Culture. And this is an output from your craft school. So tell us a little bit about that.
Well, we ran a school in those years, which it's through the medium of wooden boat building. And then we took on this project for City of Culture 2014. So this is a dinghy, essentially designed. It's a one-off. It was designed by the late TRI specifically for the school. Yeah. So there's only 4 of these, and we built the 4 of them.
Right.
And they're essentially designed to sail between the bridges in Limerick, to bring inner city sailing back into the city, which was popular before the development of the road networks in the 1920s.
Right.
And then people went further for their sailing, because Limerick is the highest tidal range. So it's not the best place for sailing, but still it can be quite exciting. So these boats are specifically for inner city, urban recreation.
And to touch back on, you mentioned the wooden boats as well. So there's a series of gandalos that you built as well, which are more fishing boat through wood. And you've also built quite a number of those and have some of them in use.
Yes, we've retained 4, and they're known as the gandalos, which is very similar to the gondolo.
Yes, indeed.
So we claim that they came to Ireland perhaps in the mind of some Italian, because the Italians were touring around in the 18th century building houses
in
and
Venice
canals,
and places.
Yes. So we took them to Venice in 2014 as well.
Right. Okay.
So and they were very, very similar to the local boats there. But they're magnificent, very elegant fishing boats.
Yeah.
And recreational boats, and we raced them.
Very good. But getting back to the concept of getting people involved in, using their hands, old craftsmanships, and bringing people who may never have touched on this type of work before, or pastime for that matter. You've put a lot of people through your school now at this stage.
We have, and it continues. Our workshop is there no more, but we're now a floating workshop. Our significant vessel, the Island, which is Ireland's last surviving cargo vessel, really, that continues as a floating classroom. But we did, for 12 years, have a workshop and we built boats like this. We built 20 boats in total. So we brought a lot of people into that project.
Right.
If people in Limerick City and beyond, and we had craftspeople who come in from different parts of the world. So it was a great mix of people. And so you could come in for a very simple just experience of learning how to use hand tools, or you could take it further and learn how to build a boat.
And what I've seen recently, particularly with Island, that you're starting to look at, using the vessel, which is a most beautiful vessel, but to reimagine the old trade functions that those boats had in the days that they were originally built. And I think you've had a few journeys where you've brought barrels of, liquor and things like that from port to port. And again, is that something that you're trying to stimulate ideas, or what is it? How would you describe what you're setting out to do in terms of those traditions?
Well, we're celebrating the tide, because Limerick is essentially an Atlantic. It's a unique expression of the Atlantic. And the Shannon estuary is the Atlantic. And Limerick City, where we're based here now, has the highest tidal range in Ireland. So we can leave Limerick City and travel anywhere to any other coastal community in the world. And so what we're doing is we're showing that cities are cosmopolitan. They're not sort of bubbles, that they are, that you can reach out, you can sail forth and leave the city and sail. And so this is how Limerick came about, really. Herodotus said that Egypt was a gift to the Nile, and I would say that Limerick is a gift of the tide.
That's a great way to put it. That's fantastic, yeah. So it's wonderful to hear that this kind of work is continuing, that it reaches back into the traditional crafts. But, we're talking today a lot about innovation. This is innovative. There's nothing that's different to what, we're talking about autonomous vehicles earlier, to what's going on in your world. So I really want to say, Gary, thanks to you and the team that's around you for inspiring a lot of people to get in touch with this type of innovation. And I think, I'm hoping there's a lot more to come as the years go by.
Thank you very much, David.
Thank you. Hi, it's Dave here again, and now this time I'm with Dooley, who is a lecturer in the Department of Electronic and Computer Engineering at University of Limerick. Ger is also an investigator as part of the Confirm team. So welcome, Ger, and you've got some really interesting kit here that we can talk about, the context of it, what it is, and maybe talk about some use cases as well. So over to you, Ger.
Yeah, so I'm working in Confirm and University of Limerick. This is a traditional vertical takeoff land drone. It can do maybe 50 minutes in the air. And what we're developing in UL and within Confirm, we're developing machine vision systems that can be used on these drones to replace the pilot really effectively.
Sure.
So I guess the modern day commercialization, which is coming for drones maybe in 10 years, the evolution of drones is we're moving basically from manned pilots to automated pilots. And there's a lot of development that needs to happen really around that. So these drones can do maybe 50 minutes in the air, and they can do various missions such as inspection, survey with lidars, and they can do various standby things. So that there's also deliveries is what we're showing today.
And when you say moving from manual pilot, you mean somebody who's actually using the controller to having something like an AI system actually programmed to manage it?
So where the drones are at the moment is you have a pilot running it off a controller, as you can see here. And the pilot is regulated by Irish Aviation Authority,
of course,
and by European Commission. And the regulation is that they have to be within, say, 400 meters visual line of sight of the drone at any given time. And there's other regulations as well. But if we're to move to automated, so if we want to eliminate the need for the pilot, and we want to eliminate that 400-meter barrier, which unlocks a lot of commercialization down the road, we need to replace the pilot's eyes with machine vision eyes and computer vision systems. So some of the risks that we're trying to mitigate through computer vision is say a manned aircraft comes into our airspace. And that's where the regulation is worried about. That they're worried, say, if we have drone deliveries in the future like this, or say larger drones that can deliver, say, 40, 50 kilograms of payloads, which you will have in a number of years. Sure. They exist already, but they're not able to operate because of these regulations.
Sure.
So what we can do is we have an autonomous machine vision system on board, which we developed in UL, and this will tell us whether there's a manned aircraft has come into our airspace. Okay. And we can automate it then. We can say, if a manned aircraft enters our airspace, automatically descend and land your drone.
Sure.
So we can mitigate all that through AI and through machine vision systems.
Excellent. And we were chatting earlier, and you mentioned European projects. So there's obviously an interest in this type of technology across the European region. And in fact, there's some trial programs that you're running at the moment. You mentioned ports and so forth.
Yeah, so we're working on 2 European projects. One is with this type and this class of drone here, and where the use case is built around Hamburg Port Authority. Now, Hamburg Port Authority has a port which goes across, say, 50 kilometers. Wow. And it's difficult for them to be able to maintain and inspect all their infrastructure. And even if you look at bridges across Europe, they're not inspected routinely to the degree that they should be inspected. And the reason being is that the current systems, if I want to inspect a bridge thoroughly, I need to basically shut down the bridge, get a manned crew out, and it might be shut down for a day or 2 days.
Right.
So I can get around that by using drones. But I also, if I want to move around the port up to that 50 kilometer, instead of having like 5 teams of people, I just have a single autonomous boat, and I have an autonomous vehicle like this one here that can automatically move between stations and can inspect each bridge or ship that the port needs us to inspect.
Fantastic. And so the development work for this is really around the software and the control systems for this. Obviously, not necessarily developing the hardware, but it's really around the software development, and that's happening locally at UL with your teams. It's fantastic. Now, I know we've got something much more large scale over here, which is more of an aircraft rather than a drone, but it's got some drone concepts as well. So take us through, again, what it is, and again, touch on the use cases as well.
So this is our second large project that we're working on at the moment. And this hardware, this system is developed and built by a small manufacturer out in Shannon called ATEX-In. And we work closely with them then to develop some of the software systems, the machine vision systems and the AI systems that will be embedded on this drone. So we embed that into the hull of the drone as embedded computing systems. And it's the same sort of systems that we're developing. It's just a different use case, but it is specialized software that there is a significant development to go, say, from that small machine to this one. And the use case we're working at with this, it's a funded project through Enterprise Ireland.
Okay.
And we're working with a number of SMEs and commercial entities in Ireland to develop this platform that can autonomously take off and land from, say, naval patrol vessels off our shore. So currently we have naval patrol vessels off our shore that will do different transects and surveys to enforce border security. Now, the use case we're looking at is drug interdiction, but there are many other use cases for this vehicle. This vehicle, it has embedded batteries for the vertical takeoff and launch point.
So this framework here allows for the vertical takeoff. Okay.
Yeah. So you have 2 boom arms, 4 propellers on each side. And I guess if you just look at these 4 propellers, it's a similar system to what you just looked at there.
Yeah.
But on top of these 4 propellers and booms allow us to vertically take off. So we can mount it on a vessel and it takes off straight up to, say, 20, 30 meters.
Sure.
Once it gets to 20, 30 meters, we're using a traditional 100cc engine that you can see in the front. Now this is petrol based.
Okay.
And we get 6 hours of flight on this. For the battery based vertical takeoff and land, we get 3 minutes. So you can see the difference between, say, petrol engines and batteries.
Sure.
So we're using both systems to be able to do our long range surveys. And this vehicle here can do 6 hours flight. So it can survey up to, say, 600 kilometers off our coast, which is significant. And if you think about that, we can do that survey in, say, a couple of hours. A Navy vessel consumes a significant amount of fuel and also crew time and vessel time to be able to do that survey. We can do this in a few hours, and on top of that, we can have maybe, say, 3 or 4 of these systems operating simultaneously as a swarm. And you can control that all, say, from one ground control station, which is based on the vessel, or we can also do it from shore, so we can operate these from shore.
Well, that's really fascinating. And, you know, the point that we've got to take away from all of this, the development of this capability is right here on our doorstep at the University of Limerick with all the teams. It's tremendous, it's interesting, and it's certainly the way of the future. So, Ger, thanks a lot for all your contributions, and I'm sure a lot of people will want to hear more, so they'll be in touch. So,
that's great.
Thank you, Ger. So now I'm going to go and speak with Dr. Owen OConnell, also from the Department of Electronic and Computer Engineering, and we're going to talk about the immersive cave. I'm delighted to be here with Owen OConnell, Dr. Owen OConnell, who's a member of staff of the University of Limerick, but is also a funded investigator and a member of the Confirm team, basically, as an academic collaborator, as a funded investigator, working with industry, working with core research to bring about great outcomes. Now, we're standing here at the door, Owen, of the amazing immersive cave, which is part of the facility here at the Confirm Centre. So maybe you could explain to us a little bit about what this cave is all about and what its purpose is.
Okay, so thanks, Dave. This is an 8-meter diameter immersive cave, and people may not know what an immersive cave is. So basically, the best way to describe it is it's actually a virtual reality room for groups. All right. So we do a lot of training in virtual reality. We have a lot of VR setups outside on the production floor, as is at the moment. And one of the other things that we actually do is we do VR training, and so this is a nice way to actually do VR training without the actual. Some people find that the VR headsets can be kind of disconcerting, so we can actually train people without the actual discomfort of the headset being on all day, all the time.
I see. So it's not dependent on the headset.
Yes.
The experience is actually through what's delivered through the walls of the room.
Effectively, if someone was out on the production floor using a VR headset, we can replicate it live in here, and we can see how they're actually interacting with equipment on the production floor, and we can actually. So it can be a shared experience without it being everyone. So we use it as a training room, a training facility. And another thing we use it for actually is because it effectively is around cinema, right? It's the best way to another good way to describe it. We use it for education and public engagement. So part of the Conform remit is to actually engage with secondary level schools. And so we actually bring school tours in here, and we've created a video explaining, it's a 6-minute video explaining what is Industry 4.0. We go through the evolution of Industry 1, Industry 2, and it's just so that, because it's such a buzz term at the moment, Industry 4.0, that the youth of today would not be aware of it. And it's part of our remit to actually develop the talent pipeline to get people interested in STEM. So that's
and this helps to build that awareness.
It does.
Through an experiential set of
and you can see at the moment in the background where this is what it's like to be a box going down an assembly line. And but we have other videos and other interactive methods that we can use. So, for example, we can actually, one thing that we can do is we can actually do a CAD simulation of a production floor line, assembly line, and then we can actually replicate it in here, and we can show what it's like to be inside a full assembly line, walk around the assembly line, and so they can actually see what it's like, and we can replicate that on anywhere that has a CAD drawing, and we can actually put it in here.
So in a way it can also act as a test bed.
Oh, it's a full test bed.
For the development of this type of content.
Yeah, and another thing then as well that another buzz term that people are talking about is digital twins. So what we can do is we can actually have a manufacturing line out there. We can actually have a live version of it digitally in here. And going forward, the plan is actually to be able to actually make a digital change and press go so that it actually gets affected on the real world line out in the production floor. So it's a two-way communication. So this is more like we can interact with it virtually, test it, and then validate it, and then apply it. So that's the kind of the achievement that we're striving towards with this.
Sounds exciting, and I can imagine that when you do have younger school kids and that coming in here, it's quite an exciting experience to be able to offer that in what is very much an industrial type of environment. So that's really something else.
Yeah, it is key to one of our goals. The more we can interact with people who aren't in the STEM sector as such, to get them interested is a key KPI for us.
Driving awareness, driving the thinking about what STEM from a career perspective can bring, because as we all know, there's a dearth of demand coming through the pipeline. We've got to stimulate more and more.
It's unbelievable.
The demand,
the demand from industry. So you mentioned at the beginning, like I'm an academic in the electronics department here in the university, and the demand that we are getting from industry for more engineers, more software programmers, more bespoke skill sets. That how do we actually get people interested in that? And what we have to do is we have to actually show the bigger picture so that they can actually refine as they go through. So this is, we're trying to, I don't want to say sell, but get the bigger picture across to the wider public, and that's why we use
and of course the other thing, you can't just tell folks anymore, you have to show them.
You have to show it,
you have to immerse them, hence the cave. So Owen, it's been fantastic just to get that briefing from you. It's really something that you know, the more and more people can come through these doors and get this experience, the better. Particularly our youth, particularly people who we want to see as the future pipeline of our talent. So Owen, thanks for your time.
No problem. Thanks, Ed.